Hello, good everyone. This is a mathematical intelligence sponsoring maths intellectual tutorials, and we continue from where we stopped in our previous video on the integration by parts. So, integration by parts. Today we are going to be looking at further examples, some other examples that may be a little bit difficult or a little bit more complex. At least, literally for today, we are going to look at one major example that I feel that as problem might give future problems when you are trying to solve problems under integration by part. So every other problems is just like a walk in the park. So let's look at this example. So if we have, let's say we have y is equals to the integral of exponential x cos x dx. So let's look at this example quickly. When you have this kind of example, so how do you solve this problem? We have this problem here. So how can you solve this problem? Same thing we did yesterday, same thing we are going to do today. We are going to use our Laet rule. You know, from our formula of integration by parts, we have what? Integral of what? U dv is equals to uv minus integral of v du. So this is the formula for. So how do you solve this problem? So we know that what we are going to have to know which one out of this exponential x and cos x, which one is going to be our u and which one is our dv. I guess now. So we'll now use this formula here to now further solve the problem. So, and I introduced yesterday our Laet rule, which we are going to be using to fish out which one is going to be our u and which one is going to be our. So, and according to Laet rule, we have exponential here, and we also have here, we have trigonometry, which is cos x. I get it now. We have cos x, which is trigonometry. We have exponential x, which is exponential. So, and according to Laet rule here, you see that your 3 comes before your exponential. That means our u is what? Cos x. So this will be our u, which is cos x. I there. So that will be our u. So since cos x is our u, so that means our dv is what? Exponential x. So from here we have u is equals to what? Is equals to cos x, and our dv is equals to exponential x. I there. That means our du will be equals to what? Minus sine x dx, rather, right? And our v, which is the integration of this, will still give us exponential x. That will be exponential x, right? So if you look at this now, you see that your u is cos x. If you differentiate u, you have du dx, which is differentiation of cos x will give me minus sin x. And the v, if I integrate it, I have v, which is exponential x. I integrate exponential x, we still have what? Exponential x. That's how we got those values there. So from there, we can now furthermore finish up this problem here. From here, we now have what? uv, right? So this is u and this is v. uv means what? Cos x. That will be true. One side is equals to cos x exponential x. I then uv, I get to have minus integral of v is exponential x, du is minus sine x times times minus sine x. I did. So that is that about that. So from here we have what? We have what? I can write this one as exponential x cos x. I get it now. Minus this minus times this minus here give me plus. I did now integral of what? Exponential x. I did now sine x dx. This is also dx because there's a dx here also attached to this. I did now. So we have this. So since we're having this now from here we still have integration by part here again. We integrate again. We have what? We have equals to exponential x cos x plus open bracket. Now from here, we want to integrate this one using integration by part. Again, using integration by part, and we know that strict comes before exponential. That means sine x is our u and exponential x is our dv. So if your u is sine x, I don't know, and our dv is exponential x, that means that what our du dx is what cos x, and our v is still what exponential x, I don't know. So since all this is all this is there, so from our formula we can now further finish this problem, which is u v, I don't know. So integrating this now, we have u v using integration part. We have u v, right? That is let me write in a formal way as exponential s sine x u v, I did, minus integral of v, which is exponential s du. That will say something as exponential x cos x, I don't know, dx. So close the bracket. So we have this at the end of the day there. So from here, you see that we have integrated this using integration by part again to get what we have in the bracket. And from here, we have this before. And then this is our answer from here. So from here, you can furthermore solve this, which you have what? Exponential x cos x, I there, plus here we have what? Exponential x, let's open the bracket, sine x minus integral of exponential x cos x dx, I don't know. So we have this at the end of the day. So looking at this now, if you look at this critically now, this is still an integration by part again. Can you see now? So this is still an integration by, and if you discover something while I was solving, I've done integration by part twice, and this is under integration by part again. You will discover that if I use integration by part for this, I will still get another problem that will use integration by part. So I'll see if I solve that one again, I'll still get it using integration by part, like that, like that, like that, keep on going like that. And if you look at this problem critically, if you look at it from here, from our question here, look at it here, from our question, we have this cos x. From here we have this here, I there. So and from here, let me look at our question. From our question, we have what? Exponential x cos x. We integrated this one to get integrated this here to get this, which is what we have here, and still we integrated this to get what we have here, which is our cos x exponential x. And if you look at this problem very well, if you look at it very well, you will see that here, this one here is the same thing as what we have here. Can you see it? So since if you look at it, when we integrated exponential x cos x, we got this one what we have here. We integrate again, we got this one. If you integrate again, you get something that has like sine. If you integrate again, you get something that has like cos. I get it now. So it keeps on going like that. So because of that, we need to find a way to find a final solution to this problem. And how do we do that? You see that this is the problem here, which we integrated to get what we have at this point. I don't know what we have here. So from this point here, if you look at this, which is this, it is the same thing with what we have here. Can you see it now? So exponential x cos x here is the same thing as what? Your integral of exponential x cos x here. Can you see it now? You see that integral of exponential x cos x here is the same thing as is written here again as integral of exponential x cos x dx. I don't know. That is y equals to this. Can you see now? From our question, y is equals to this here, y equals to this here, and we still have that same value here. That means I can replace this integral of exponential x cos x dx here with my y, because from my question I'm given that y is equals to this, which is what I have here. And after solving, I still get back this value here again. That means that at this point, instead of integrating further, I will replace this my exponential x cos x with the value of y. I getting it now? Are you getting logic here? Because if I keep solving this problem, it will keep giving me more problem about integration by parts and keeps on going, keeps on going. So because of that, the moment you solve and get to a point whereby you get back your question, then you can easily replace your question with the value you are given, which is y. So from here now, this will now give us something like so from here we know that our y is what we have been solving to give us this value here. Our y is what we have been solving to give us all this value we have in here. So here, like I can say our y equals to exponential x. I then now our y equals to exponential x cos x I then now plus exponential x sine x minus, now the whole of this what we have here is the same thing as your y from your question. Then now can you see it now? Because I've been solving the value of y equals to integral of exponential x cos x. I solved it, I got one value. I solved again, I got this what I have here. And you know that this thing is equal to y from our question. So y is equals to everything here from our question. If you look at it, let me jump back to question here. Look at the question. Y equals to this, and y equals to this from our question. We have been solving our value of y, which is equals to this. So when we have y equals to this, I solve this problem here. This one, what I have here, I solve it. I solve this problem here. There to give me my this. I solve the game. It gives me this. There now. So I give me this, and from there I solve it. There it gives me this, which is what I have at the end of the day. And from here, this value here is sent me as my y. And you know, for my question, I have y equals to something. The integral I've been solving since morning, which is this y is here. This y is from the question, which is here. And the integral I've been solving gives me this, which is this, and this one is still y again because value of my y is sent me as this. So I place this with y. I have this. I get it now. So this y here, I'll bring it to the other side of the equals to, what do I have? Y plus y. Can you get it now? Equals to what? Exponential x cos x plus exponential x sine x. Either now. So we have this at the end of the day. So from here, what do we have? From here we have what? 2y. I get it now. 2y equals to exponential x is common. We have cos x plus sine x. I get it now. So from here, divide both sides by 2y. Divide both sides by 2. We have y equals to what? Exponential x over 2 sine x. I get it now. So which is our final answer at the end of the day? So the final answer for that question is this, what we have here. So recap from our question. I want to quickly recap. Sorry. I want to quickly recap from our question. Use another pen. From our question, we have gotten our answer though. From our question, we have your y, which is equals to this, and from here we solve this integral here to get our first problem here, which is what I have here. And from here I solve for that again. I use integration by part for this one here, and I got I use integration by part for this one here, and I got this. I got this here. What I have here, I got this here. And if I furthermore use integration by part again, I use integration by part, I got this. And if I furthermore use the integration by part for this value here again, I'll still get exponential s sine x again, which will still furthermore keep going like that. So because of that, I will not furthermore from here, because I know that this one here is equals to my question, and my question is y. So I place this one with y, which is what I have here. I place this here with y, which is what I have here. And then for my question, I know that this is y already. For my question, this is y equals to integral of something. That is the integral I've been solving. and this y here is here, it has been here always, and this one you place here, this one here I place with it what I have here, which is my y, and this minus y here I bring it to the other side of the equals to give me plus y. I get it now, plus y. And from here I can now, from here I now add these two together to give me 2y. I get it now, and this 2y, this here, this here gives me this, and then bringing out exponential, we have exponential here, and we have this here, and from here divide both side by 2, I have exponential x over 2, and then you have your final answer. And this brings me to the conclusion of today's class, which is under integration by parts. So this is how you solve some other, this is another way kind of problem under integration by parts can come, and through that you can, through this idea, you can solve questions that looks like this, because of questions that has to do with continuous repeated values of your partial derivative. You have to keep using partial derivative, keep using partial derivative every time. So because of questions that you have to be quick using partial derivative every time, then we introduce this kind of problem, this kind of system, or this kind of method to solve this kind of problem by, when you integrate until you get a value whereby it is equivalent to your question, then you can just replace the variable given, maybe your y or maybe z you are given there, with what you have on that partial integral that is the same as what you have in the question, and then you furthermore solve from there and you get your final solution. So very easy, very simple to solve, and there's no issue with it. So this is majorly how to solve. So through this you can solve problem like this, and through my previous video you can also solve problem on the integration by parts. So this is how we stop for today, and see you probably in my next video.